Okay. So next we are discussing a very important topic, relation between E and V. Okay. So basically E is nothing but force experienced per unit test mass. This is called as E value number. And what is meant by potential? Potential is nothing but work done per unit test mass. So see carefully when you observe here I have force and here I have work done. Okay. So force into displacement is nothing but work done. Okay. So generally, actually we should not say like this, just for your understanding I am saying. So E into S is equal to F into S divided by M naught. Can I write like this one? I am multiplying by displacement on both sides. Okay. Then force into displacement, work done per unit test mass. Work done per unit test mass, potential. So just for your understanding purpose, I can write like this. Are you able to understand? So E into S is equals to V. Okay. So therefore, the general relation, or I can write E is equals to V by S also, no? E is equal to V by S. I can write like this. So therefore, this is not the method of derivation. There is some another method of derivation, but I am not going for that method because it doesn't require that one. Just for your understanding purpose, I am writing this. Okay, ma? So therefore, the relation between E and V is E is equals to minus delta V divided by delta S. This is the relation. Okay, ma? So how much potential is changing per how much displacement, or for a particular displacement? That relation is called as field at a particular point. So E is equals to minus delta V divided by delta S. Okay, ma? And if I want to write in differential form, okay, ma? In differential form, if I write, then in differential form, how can I write? I can write E is equals to minus dV divided by ds, or you can write minus dV divided by dr. So this is the relation between E and V. Understood, Nama? So, and V also I can write like this, I can write minus dV is equals to E into ds. I can write like this, no? So dV is equals to minus of E into ds. Okay. If you apply integration on both sides, clear? Then what I will get? I will get delta V. Delta V is equals to minus integration of E into ds. Okay. ds or dr, limits are applied from S1 to S2. And delta V is nothing but a change in potential number. So you can write V2 minus V1. Final potential minus initial potential is equals to minus integration of E into ds. Limits are applied from S1 to S2. So this is another equation to define relation between potential and electric field. Are you able to understand how we have proceeded? So this was the relation I got by using some symmetry, and that one I have converted into relation. Okay. And a differential form means what? dV means change in potential. Differential change means very small change. Very small change means I have to write in terms of dV. So minus dV divided by ds or dr, anything both are same. Similarly, if I integrate it on both sides, then this is one more relation which I will get. So V2 minus V1, change in potential is nothing but minus of integration of E into ds. And limits are applied from S1 to S2. It means I have to start integration from S1 and I have to move up to S2. Okay? That's it. Make a note. Okay, so see here, this was the relations which we have derived, no? See here, electric field, it is a vector quantity, no? Electric field is a vector quantity, but potential is a scalar. So you should remember always that point. Clear? So see here, what is meant by electric field? Force experienced per unit test mass. Sorry, not electric field, gravitational field. So gravitational field is nothing but force experienced per unit test mass. So therefore in vector form you can write like this, because it always has a direction. Okay. But potential is a scalar quantity, because potential is nothing but work done, no? And work done, is it a scalar quantity or vector quantity? Work done is scalar, so potential is also a scalar. So this is a vector quantity and it is in the direction of force itself. What is the direction of force experienced by test mass? Same will be the direction of electric gravitational field. And this is a scalar quantity, it doesn't have any direction, just you will get either positive value or negative value. If work done is positive, potential will be positive. If work done is negative, potential will be negative. That's it. Okay, ma? So we write one case. Case is that if gravitational field is existing in all three dimensions, okay, ma? Or any two dimensions also you can call. So gravitational field, it is a vector quantity, no, ma? It can be existing along x-axis also, along y-axis also, it can be existing along z-axis also at the same time. That is possible. Okay. Therefore, in that condition, E value, how I can write? E value can be written as E dash is equals to Ex I cap plus Ey j cap plus Ez k cap. I can write like this number. If electric field is present in all the directions, along x-axis also it is present, along y-axis also it is present, along z-axis also it is present, then I can write equation like this. Are you able to understand? Similarly, if you take that equation, E is equals to minus dv divided by dx or dr, okay ma? Then if I write in vector form, I can write E dash, or I can do one thing, okay ma? So, minus dv can be written as E into dr. Can I write like this ma? Already we have written, no? So, minus dv is equals to E into dr. So, dv is what kind of term, scalar or a vector? It is a scalar, no? But field is a vector quantity. Dr is a? Dr means direction. Direction is also vector quantity, no? In which direction this field is present, along x-axis or y-axis or z-axis. This is also a vector quantity. Two vector quantities, if I am multiplying, I am getting a scalar. Then it is what kind of product? Dot product. Clear, no? So therefore, in vector form, I can also write minus dv is equals to E dash dot dr dash. I can write like this also. Are you able to understand why I am writing? Because two vectors are multiplied, but resultant is a scalar. It means definitely we are doing dot product. So therefore, E dash dot dr dash is equals to minus dv. You can write like this. Okay. So therefore, okay ma? And if a field is existing in all three dimensions, then the dr dash also, how you can write? I can write a dx I cap plus a dy j cap plus a dz k cap. I can write like this, no ma? Okay. If field is existing in all the three dimensions, then the displacement also I have to consider in all the three dimensions. Displacement along x-axis, displacement along y-axis, and displacement along z-axis also I have to calculate. Okay. And if, for example, if person is given like this, if v is equals to 3x square yz, okay ma? Are you able to understand? So, first of all, make a note up to here ma. We will do some problems, then we will understand. Make a note up. Okay. See ma, here this is the given question. So electric field, gravitational field at a point is given like this, minus 2x I cap minus 3y square j cap. So this is the magnitude and direction of the gravitational field. It means gravitational field is present along x-axis also, it is present along y-axis also. Both directions it is present. Then he is asking if potential at origin is 0. Potential is always a comparable quantity, like potential energy. So at which point he is taking potential to be 0? Potential is taken to be 0 at origin, 0, 0. Then find potential at 1, 1. That is the question. Okay. So definitely one point which I can say is field, gravitational field is here along 2 dimensions. Okay. It is along 2 dimensions, it is existing along x-axis also, it is existing along y-axis also. And we are supposed to find out potential. So what is the equation we have written? V2 minus V1 is equals to minus integration of E dash dot dr dash. Limits are applied from where to where? 0, 0 to 1, 1. That's all. No? This was the equation we have written previously. So change in potential, nothing but V2 minus V1 is equal to minus integration of E dash dot dr dash. And dr is nothing but displacement number. From where to where I have to find out? From origin to 1, 1. Origin already he gave 0, 1, 1. Clear number? So therefore, potential at 1, 1 minus potential at 0, 0. Can I write like this? This is the final potential, not 1, 1. This is the initial potential at 0, 0. So this is equals to minus integration of, what is the field value which he gave me? So minus 2x I cap minus 3y square j cap. Dot product of dr dash. Now can you say, how can I write this dr dash? Dr dash ni ela rayachu cheppandi. Everything is on the board itself. Dr dash can be written as dx I cap plus dy j cap. That's what I have written here, no? Okay, ma? If field is existing on only along one direction, no problem. If it is existing along 2 or 3 dimensions, then this is the method in which I have to write. Same equation I have written. Okay. Now this is dot product. No? What is the formula of dot product? When vectors are given in vector form, that is in component form x1, x2 plus y1, y2. So multiply according to that. So potential at 1, 1 minus, can I write it as 0, ma? Because potential at 0, 0, he gave 0 only. No? So this is equals to minus integration of, now this is x1, this is y1, this is x2, this is y2. What is the formula of dot product? x1, x2 plus y1, y2. So x1, so minus 2x, okay ma, multiplied by x2. x2 is dx. That's all. No? So this is one product, okay, and y1, y2 plus y1. Which is y1? Minus 3y square multiplied by, which is y2? y2 is dy. That's all, nama? x1, x2, y1, y2. Okay. So this is the value which I have to write. And what are the limits? The limits are applied from 0, 0 to 1, 1. This is the value which I have to write. Are you able to understand how we are proceeding? Now let us see. So now we will separate the integration for x-axis and separate the integration along y-axis. So therefore potential at 1, 1 is equal to how much? So minus of integration of minus 2x into dx, and along x-axis from where to where I am moving from 0 to 1. That's all, no? So limits are 0 to 1 along x-axis. That's all, no? I want to move from 0, 0 to 1, 1. It means along x-axis 0 to 1, y-axis also 0 to 1. So again minus integration of y-axis also 0 to 1. Now along y-axis minus 3y square multiplied by dy. Now you can do this integration values, no? Okay. So minus into minus plus. Here also minus into minus will become plus. So 2 minuses will get, no? That's it. So therefore do the calculation. So integration of 2x dx is how much, ma? 2x square by 2. Limits are applied from 0 to 1. Plus 3y squares, 3y cube divided by 3. Limits are applied from 0 to 1. Okay. So this is potential at 1, 1. So therefore 2 get cancelled, 3 and 3 also will get cancelled. If you substitute the limits here, then I will get 1 plus, and here also if I substitute the limits, I will get 1. So 2 volts, that is my answer. 1 plus 1 is 2. Is it clear, ma? Rules of integration, I hope you can understand. No? So integration of x power n dx is how much? X power n plus 1 divided by n plus 1. That's it. Make it out. Okay, my unit of potential is not volts, ma, here. Okay. So potential is nothing but work done per unit mass, no? So joules per kg. That is the unit of potential. Okay. Okay, ma? Now see. So therefore, this is the next question, ma. So potential at a point is given by v is equal to x square y. How it is varying? That's he gave x square into y. Then we are supposed to find out potential at 1, 2. Okay, so here one point which I can see is potential is depending on x-axis also. Potential is depending on y-axis also. It is depending on both x and y. No, it means that field is present along x-axis also. Field is present along y-axis also. That is the meaning of this one. Okay, so therefore, what is the note point here? I have to write point is that potential is dependent on x and y axis. Therefore field is two-dimensional. Okay, ma? Field is two-dimensional. Therefore what I say, therefore general relation is E is equals to minus dv divided by dr. This is the relation, no, ma? Okay. But because v is present along both dimensions, and here x is also present, y is also present, no, ma? So therefore what I will do is, I will do partial differentiation, ma. E x is equals to minus dou v divided by dou x. It means I will differentiate only the x values only. That is called as partial differentiation. Okay, ma? So if I am taking differentiation along x-axis, then x is a variable, y is a constant. That is called as partial differentiation in mathematics. Understood? No? Similarly, Ey, how I will take, it is minus dou v divided by dou y. I will take like this. So in this condition, x is variable. What about y? Y is a constant. Okay, ma? In this condition, second condition. Okay, ma? Y is a variable and x is a constant. This is called as partial differentiation. Understood now what is happening? So if V is given, then these are the methods of calculating E value. So you do partial differentiation along x-axis, partial differentiation along y-axis. Then you will get field along x-axis and field along y-axis. Then you will get the total field. Understood now? So let us see. So therefore, let us calculate Ex. Okay. So Ex value, how I can calculate? Minus dou V divided by dou x. So minus dou by dou x of V. What is V? X square into y. Okay. So therefore it is equals to minus of differentiation of x square is a 2x and y is a constant. Minus 2xy. Understood, Dhamma? Partial differentiation means what? One value is a constant, another value is a variable. So here which is a constant along x-axis, y is a constant. X is a variable. So y you take out of differentiation, minus y. Differentiation of x square, 2x, minus 2x. Satisfied? Okay. Similarly, I will do Ey. What is Ey? Partial differentiation along y-axis. So minus dou V divided by dou y. Dou means partial differentiation. So minus dou by dou y multiplied by, and what is the equation of potential? X square into y. So here who is a constant? X square is a constant. So take it, x square you take out of the differentiation. So dou V divided by dou V. Dou V divided by dou V is how much? 1. They will get cancelled. Okay. So therefore minus x square. Are you able to understand? So therefore write down the total equation. So therefore E dash is equals to Ex I cap plus Ey j cap. This is how I have to write in vector form now. Field along x-axis, field along y-axis. So do the calculation. Ex value is how much? So minus 2xy I cap plus, minus is there, minus x square j cap. That's all. This is the field in vector form. But I want magnitude, no? He is asking field at which point? Field at 1, 2. So substitute 1, 2. So therefore field is equals to minus 2 into, what is x value, ma? X value is 1, y value is 2 I cap, minus x square 1 square j cap. So therefore how much? Minus 4 I cap minus 1 j cap, or just j cap you can write. So this is the vector form of field. Okay. If you want its magnitude, then what you can do? Magnitude is equal to square root of minus 4 whole square plus minus 1 whole square. This is how I can calculate magnitude number. So therefore it is square root of 16 plus 1. So root 17 Newton per kg. That is the magnitude of electric field. Sorry, gravitational field. And vector form, this is the equation. Okay. So minus 4 I cap minus j cap. That's it. Understood, Amma, how to do partial differentiation? So if potential is along 2 dimensions, it is depending on x-axis also, y-axis also, then you have to take the help of partial differentiation. Okay? Because if field is potentially is varying along x and y, then field is also varying along x and y. So therefore this is the method of calculating field along x-axis, and this is the method of calculating field along y-axis. If you are doing along x-axis, then x is a variable, y is a constant, like this. Method